In this video, we will be discussing one of the most important laws found in electrochemistry, Ohm's law. In electrochemistry, we study the relationship between electricity and chemical reactions. Electricity can be generated by the movement of electrons from one element to another in a reaction known as redox or oxidation reactions. Electronic circuits display many of the basic laws of electrochemistry, but how can we simply analyze a circuit? We do this by applying Ohm's law. Now, what is Ohm's law? Ohm's law states that the strength of a direct current is directly proportional to the potential difference, while also being inversely proportional to the resistance of the circuit. And from this definition, we're able to determine that there are three components involved in Ohm's law: voltage, resistance, and current. In Ohm's equation, voltage is equal to the resistance multiplied by the current. And we will be looking at each component individually to better understand what they mean and also learn how to calculate each by using and rearranging Ohm's law. First, we have resistance. Now, resistance refers to a measure of the opposition to a current flow in a particular electrical circuit. The unit of resistance is ohms, and the resistance formula is given by R is equal to V over I. We're given this formula by rearranging Ohm's law to make resistance the subject. V over I is voltage over current. Voltage is in volts and current is in ampere. To better understand resistance, here's a life example. Imagine a person moving from one end of the market to another, but struggling due to the crowd of people in between. This resembles how resistance affects the flow of electrons moving through a wire. A point to remember is that electrons will always move to the positive end due to them being negatively charged. Here we have three circuits to help us better understand and visualize the effect of resistance on current. As we increase the resistance from left to right, we can see that the current will decrease. This means that current and resistance are inversely proportional to each other. Next, we have voltage. Now, voltage is the pressure from an electrical circuit's power source that pushes charged electrons, current, through a conducting loop. Voltage is measured in volts and can be given by the formula V is equal to I multiplied by R. I is current and R is resistance. Here we can see the effect of voltage on current. Now, moving from left to right, as we increase the voltage, the current will proportionately increase as well, meaning that if we double the voltage, the current will double. And we can see how electrons flow much faster at a higher voltage due to a higher current. That means that current and voltage are directly proportional. As we increase the voltage, we're going to also increase the current. Lastly, we have current. Now, current refers to the flow of electricity in an electronic circuit or to the amount of electricity flowing through a circuit. It is measured in ampere and can be given by the formula I is equal to V over R. Now, some examples of current are starting a car, turning on a light, playing video games, and charging a cell phone. These actions all lead to the flow of electricity. Now, the three circuits here describe the relationship between current and resistance. And like we said prior, resistance and current are inversely proportional. This means that as current decreases, we can assume that the resistance is getting higher. We've already been discussing the relationship between voltage, current, and resistance, but here we'll look at some graphical representation of those relationships found in Ohm's law. The first graph describes the relationship between current versus resistance, where current is the y-axis and resistance is the x-axis. As we increase resistance, the current will decrease. This results in a decreasing slope, meaning that resistance is inversely proportional to the current. In the second graph, we describe the relationship between current and voltage, and we can see that we have a linear relationship, meaning that voltage and current are directly proportional. As we increase the voltage, the current will increase proportionately. To conclude everything we've learned about today, let's look at Ohm's law's triangle. Now this will help you if you find it hard to remember all the concepts related to Ohm's law. Now the basic idea of a law triangle is that you focus on the value you want and see what's left behind. So here we want voltage, so what's left behind at the bottom is current and resistance. Because they're side by side, that means that they're multiplied to each other. This gives us V is equal to IR. Voltage is equal to current multiplied by resistance. And because they're multiplied, that means that voltage is directly proportional to current. Next, we're trying to find resistance. So what's left behind when we look at the triangle is voltage on the top and current at the bottom, which means that voltage is divided by current. So R is equal to V over I. Resistance is equal to voltage divided by current, which means that resistance is inversely proportional to current. Now we want to find current, so what's left behind is voltage at the top and resistance at the bottom, giving us I is equal to V over R. Current is equal to voltage over resistance, meaning that current is inversely proportional to resistance. And hopefully that's everything you need to know about Ohm's law. Thank you for listening.